Okay, so part of what was on your last quiz that a lot of you made mistakes on was multiplying a monomial with a polynomial. Notice that we have a 2x right here. A lot of you forgot to distribute the x as well, and maybe just distributed a number, right? You want to make sure that this x, you need to be aware that that has an exponent of 1. This x also has an exponent of 1, so when you go to distribute this to this, we get 2 times 2, which is 4, but I also get x times x, which is x squared. A lot of you forgot the exponents. All right, minus 2x times negative 2. 2 times 2 is 4. There's nothing to multiply with the x, so we get this as our answer. All right, are we okay with that one? Good, more multiplying. If my monomial is 8b to the third, I can distribute that to each term in this binomial. Multiply the number with the number. 8 times 4 is 32. b to the third times b. Keep in mind this b has an exponent of 1. It's going to be b to the fourth. Again, don't make that mistake again. A lot of you did that. And then when you distribute 8b to the third times negative 4, I'm going to get a negative 32 b to the third. And that's all you have to do. All right, here, same exact thing. 2b times 3b. Help me out. What does that get you? 6b squared, right? There's 2b's, and 2 times 3 is 6. Minus, what's the next one, guys? Minus 10b, just 10b. There's only one b. All right, easy? All right, shouldn't be too bad. All right, what about this one? This one's just a number. This is a case where nothing changes to your variables. There's no variable to multiply it with. When I distribute 7, what's my first term? 28m squared. The next one, if I distribute to the next one, 7 times negative 5m. Should get you negative 35m. And then 7 times 3 should just get you 21. All right, not bad. All right, same idea here.
I have a question.
Yes. Yeah, that's a good question. So if there's no variable next to our number that's being multiplied out front, you're just multiplying the number with the number, leave the variables alone. Yeah, so if you have the same variable, you add the exponents, right? Remember our multiplication rules, if I have x to the, m times x to the n, that's the same as if you add the exponents. Right, you guys had a test on that not too long ago. So for example here, 5x squared times 6x squared, number times the number, what is that? 30, and then I have a variable times the variable. X squared times x squared is what? X to the fourth, good. All right, and then you do the same thing with the next one. 5x squared times 2x, number times the number is 10, good. And then x squared times x, what does that get you? Okay, this will get you plus 10x, right? 2 plus 1 is 3. All right, don't forget that this x has an exponent of 1. And then minus 5 times 4 is negative 20. And then there's nothing to multiply with the x squared, so you just leave the x squared alone.
Where did you get the x from?
Which x?
For 20x.
For 20x, it came from the one that was out front right here. I'm multiplying that whole thing. All right. Good. So same exact thing with the next one. 4m, I want to multiply this whole thing, this entire monomial to each term in this trinomial. So you can do your number times the number. 4 times 6 is 24. M times m squared. Keep in mind this m has an exponent of 1 if you don't see it. And then you have to do 1 plus 2, which is 3. So you get 24m to the third. What's this next one going to get you? 4m times 5m. 20m to the second. Good. And there's a minus there, so I'm going to keep that sign. Minus 20m to the second. and then minus 4m times negative 2. It's going to be good. Very good, guys. So this is your answer. All right, any questions on these? All right, good. So now we're going to go in the opposite direction. Question?
What would be 3, right? 3 would be here. Or it would just be 2.
2, yeah. There's a B and a B. That's just 2 B's. All right, good. Factoring out the common factor. A lot of you wrote it out correctly, but I think didn't know what to do from there. If that's confusing, just go term by term. If I look at 5 and 3, or I'm sorry, not term by term, but factor and by factor in each term. If I look at 5 and 3, what are factors of 5? 1 and 5. What are factors of 3? 1 and 3, right? Do they share anything in common? They share a 1, right? But I mean, if it's a 1, you don't have to take out the 1, right? I wouldn't take out the 1. So I know I can't take out any 1s, or I mean any factors there. What about n squared and n? How many n's do they share in common? They just share 1 n. So I know that that's what I have to take out. So if I take out 1 n, if I take out 1 n from 2 n's, how many n's am I left with?
1 n.
Just 1 n, right? And there's still that 5 from before. I didn't do anything to that. 5n minus, and then if I take out 1 n from 1 n, how many n's are left over? None, so it would just be minus 3. If you wrote it out, all right, I only taught you guys to write it out because I thought that would make it a little bit easier, but I think a lot of you work better just by thinking about it. If you did 5 times n minus 3 times n, you can do it that way also, and then you can tell that they share an n, and n. So that's what you would take out. And then what you're left over with is a 5n minus a 3. So you still get the same answer, right? But you don't particularly need work as long as you think about what each factor is in each term. All right, are you okay with those? I think these ones confuse you guys a little bit. All right, so now let's look at this one. If I look at number 8, I'm going to do the exact same thing I did before. Let's go term by term, factor by factor. So if I look at the numbers, negative 32 and 40, what are factors of 32? Okay, 8 and 4. What else? Do I have other factors? Anything else readily available? Why don't we stick with that? Let's stick with 8 and 4. What about 40? What are factors of 40? 8 and... Okay, Sergio said 8. So 8 and 5, 4 and 10, right? So if you look at these factors, which one is the biggest one that they share? The 8. So that means I can take out an 8 from these. Now, if I look at v squared and v, right, between 2 v's and 1 v, how many v's do they share in common? Just 1. I can take out 1 of the v's. All right? So what happens when I take out 8 from 32, right? Keep in mind these are factors, so we should divide. 32 divided by 8, what does that get you? 4, and there's a negative, so I would write a negative 4 out front. And then if I take out 1 v from 2 v's, how many v's are left over? Just 1 v. All right. Plus, what about 40? If I take out a factor of 8 from 40, 40 divided by 8 gets you what? 5. If I take out 1v from 1v, how many v's are left over? None. So this is your factored expression. If that explanation was confusing, you can write it out. So you can write out negative 32v squared plus 40v. You can write out your factors, right, and say that 32 is 8 times 4, v times v. And then 40, you can say that that's 8 times 5 times v. And then you can see that the biggest one that they share is an 8 and a v, and 8 and a v. And then if you take that out, you still get the same answer. You're left over with a negative 4v and a 5. All right, are we okay with that? All right, next page. Okay, so let's look at number 9. Let's do the same process. So I want to find the greatest common factor of negative 20b squared plus 25b. We can go number by number. Right, so what are factors of 20? 4 and 5, right? So I know 20 is 4 and 5. What are factors of 25? 5 and 5, right? B squared you can write as b times v. And then 25 as 5 times 5 times b, right? Now, if you look at these factors in each term, which one do they share in common? They share a 5, right? What else do they share? They share one of the b's, right? So in total, I can take out a 5b. And then when you take out that 5b, what are you left over with?
Negative 4.
Okay, so there's a negative 4 and a b, right? 5, right? There's a 5 left over. Okay, so if it is a trinomial, right, it's the same exact process, but just with one more term. Right, so if you look at 35, 49, and 7. Okay, so if you look at the numbers, right, 35, 49, and 7, can we think of a factor that they share in common? 7, right? They share a 7 in common. Do we all see that? Between 35, 49, and 7. So that means I can take out a 7. Now, what about n to the 8th, n to the 3rd, and n to the 2nd? There's 2 n's, good, right? So 7 n to the 2nd. And then in parentheses is going to be whatever's left over when you take these factors out. If I take out a factor of 7 from 35, right, what do you get after you divide that? 5, good. And then what do you get after you take out 2 n's from 8 n's? 6, right? Good. What happens if you take out a factor of 7 from 49? All right, 49 divided by 7? 7, good. What happens if you take out 2 n's from 3 n's? 1 n, good. Minus, what happens if you take out a 7 from a 7? Yeah, so you're just left with that minus 1, right? And then if you take out 2 n's from 2 n's, that's also goes away. So I'm just going to write a minus 1. If you write a minus, like 0, for example, that wouldn't be correct, just because when you go back to distribute, and that's one way that you can check your answer. So if you're ever unsure about the factor that you just pulled out, you can always check your answer by distributing, same way that we did in the beginning of this review, right? If you distribute and you get your original problem, right, that's the point, right? You should end up with your original problem. All right, so we can do the same thing with the next one. Question? Yeah. All right, so number 11, if you look at the numbers, right, so again, we can do numbers and then variables. So 12, 9, and 15, they have 3? Yeah, good, a factor of 3. So I can take out a 3. And then what about p to the 9th, p to the 4th, and p?
1.
Right, they can just share one of them, right? So if I take out a 3 from 12, what's the factor that's left over?
If you take out the 3 from 12.
Yeah, like a factor of 12.
So you would divide
Yeah.
12.
4, right? And then if you take out 1p from 9, how many? Yeah, 8, right? So p to the 8th. Okay, that's that term. For the next term, think of the same thing. If I divide 9 by 3, so if I take out the factor of 3, what are you left over with? 3, good. If I take out 1p from 4p's, 3, good. And that's it for that term. The next term, take out a factor of 3 from 15. It's 5, good. Take out a p from a p. There's nothing, right? So I'm not going to write a p. And then this would be your answer. Good? Excellent. All right, one more factor problem, and then I'm going to do a binomial times a trinomial. What happened? Okay. Okay. Next one. How about you guys try this one? Try it and see what you get. I'll go over it in a minute. So when you recognize your factor, in this case, it seems like a lot of you recognize that it was 7. The 7 is going to go on the outside. It's not going to be 7x or anything just because not all of our terms have an x. Think about dividing each of your term by that GCF. Right? If you divide all of your terms by that GCF, then whatever you get left over is going to go inside of your parentheses. Right? So 28 divided by 7 gets you 4. All right, and then negative 42x divided by 7 should get you negative 6x. And then 7 divided by 7 should get you 1. So it's just going to be a negative x to the third. Question? Is that what I got up there? Then yeah, you got it. Question? All right, nice job, guys. So let's do some more products. I think yesterday I only did a binomial and a binomial, so like foiling. I won't put too many of these on your test, maybe just one, right? Because I know these might take a little bit more time. Yeah, something like these. Maybe like one of those also, I don't know. 1 or 2 of those. But for something like this, does anyone remember how we would do it? Any ideas? It's like distributing, right? Yeah, good. Yeah. So you take each term, girls, take each term. So I'm going to start with my first term, 8n, and I'm going to distribute it to each term in my trinomial. So I'm going to do 8n times 8n squared. Again, you can do your number times your number. So 8 times 8 is 64. Question? Mm-hmm. All right, and then n times n squared. Keep in mind this n has an exponent of 1. Don't forget that. It's going to be good, n to the third. 8n times 7n is going to get you, it's what, 56n squared. Again, n to the first and n to the first is n squared. 8n times negative 1 is going to get me negative 8n. That's fine. You would just combine the like terms. About what 8? Oh, yeah. Then you do that one next. So once you're done with that first one, you would do the next one. You would distribute the 8 to each term. Just the plain 8. And then 8 times 8n squared is going to get you 64n squared. 8 times 7n is going to get you 56n. And then 8 times negative 1 is going to get you a negative 8. And then from here, you want to combine like terms. It seems like the only n cubed that we have is 64n cubed, so I'll leave that alone. I have a 56n squared. I can add that with this 64n squared, right? Those are my like terms. You can only combine terms that have the same exponent over the variables. That's another mistake that I saw when you guys were adding. I think there was a multiple choice question that had the right number, but the exponents were added also. You cannot add the exponents if you're just adding the terms. You can only add exponents when you're multiplying. Like 15? About? I'm still editing it. So here you would add 56n squared. Guys. You would add 56n squared and 64n squared. That should get you 120 n squared. And then I have a minus 8n and a 56n. Negative 8 plus 56 is going to get you 48. Since you're adding, you're not adding the exponents. If you're multiplying, you add the exponents, which is how we got these terms. Girls. Minus 8. Nothing can combine with that minus 8, so you just leave it alone. And then that's your answer. Yeah, if it starts with multiplying, if you're multiplying with the same base, you do add the exponents. That's how I got this n to the third, n to the second. Right, n to the second.
Can teachers get in trouble if their students have bad grades?
Okay, for the sake of your video, I'll do one more. Guys. Okay, relax. Focus. I'll do it the other way for this one. So you can do it the other way using the boxes if you like. Girls, guys, relax. Over here, if I have a 4a plus 8, those are going to be terms over here. And then my 3 terms are going to be 3a, negative a, and 2. So it's going to be 3a squared minus a and a positive 2. What's your question?
So it's a
Yeah, so this one's going to be good. 12a to the third power. 4a times negative a is going to get you a negative 4a to the second power. 4a times 2 is going to get you an 8a. That doesn't look like 9. 3a squared times 8 is going to get you a 24a squared. 8 times negative a is going to get you a negative 8a. 8 times 2 is going to get you 16. And these are the terms that you're going to combine if possible. So we get 12a to the third. I have a negative 4a squared plus a 24a squared. That's going to get me a 20a squared. I have an 8a minus 8a. What's 8 minus 8, guys? 8 minus 8. 0. Good. So there's no more a term. And then I have a plus 16 that can't combine with anything. All right, so 2 ways to do these kinds of problems. You might see like one of these on your test. You'll definitely see a lot of the stuff that we did yesterday. So if you had like a binomial times another binomial. Or you might see the special cases. So you might see something like a binomial squared. Or you might see a sum and a difference. In all of these cases, you can FOIL it.
How would you FOIL a binomial square? Would you just square all of them and then FOIL?
So for this one, yeah, if I had something like that, there's a couple ways you can do it. There's a form that it takes that you could memorize. Or if you don't want to do that, you would write it twice and FOIL it.
What do you mean write it twice?
Like to square something means to multiply it by itself. So something like that, squared, expanded, it would be x minus 5 times x minus 5. And then like that, that's a little bit more familiar, right? You guys are able to FOIL that. All right?
I have a question.
Yes.